students, welcome to class 12 chemistry. You are with me in the last part of the unit electrochemistry. Today we are going to see about batteries. What is the difference between a battery and a cell? A cell contains the anode and cathode. A battery is the combination of one or more cells connected together in a series. There are certain conditions for an ideal battery. What are they? They should be light and there should not be any voltage variation throughout their life. All the batteries behave in a galvanic cell manner, that is they convert the chemical energy happening inside the battery into the electrical energy, and in turn this electrical energy is used to do some work like glowing bulb or running motor, etc. There are three types of battery. One is primary battery, second one is secondary, and third one is fuel cell. First we look at the primary battery. In primary battery, the reaction goes only in one direction, that is if the reactants form products and after a particular period of time all the reactants would get depleted and the cell will become dead and rather than the cell can't be used anymore. This is the primary battery. This primary battery is known as the Electro battery, and the famous Electro battery is the zinc carbon battery. So, this is the diagram of the primary Electro battery. Here the anode is made up of zinc and the cathode is made up of carbon rod. This is the cathode. Cathode is made up of the carbon rod. The electrolyte is actually the carbon black and MnO2. These two are present as solid particles, and these two solid particles are mixed together and present as paste in the form of electrolyte, and it is made up by paste with the help of aqueous ammonium chloride. We get 1.5 volt from this battery. So, these are the important components while we look for the primary battery, that is anode, cathode, electrolyte and EMF of the cell. Now, moving to the cell reaction. What is the anode? Anode, this is the zinc, right? So, zinc will loses 2 electrons and become zinc ions. This is the reaction happening in the anode region. In the cathode, see this carbon rod, that is graphite, it won't conduct. So, the MnO2 present in the electrolyte is the medium for the electron receiving. This MnO2 acts with the NH4 plus. Why I am choosing this NH4 plus means, see, cathode is a negatively charged electrode, right? So, near to the negatively charged electrode, the ammonium chloride present in the electrolyte. So, cathode is the negative electrode and near to this negative electrode positive ions present in the electrolyte get nearer to it. So, MnO2 plus NH4 plus. Okay. The electron liberated from the anode compartment always add to the cathode department. So, we are getting a product like this MnOOH plus NH3. Nothing is there, the one of the hydrogen get into this. So, MnOOH plus NH3. This is the reaction actually happening in the cathode department. Here the manganese have a valency of 4 in the reactant side and in the product it is get reduced to 3. The zinc formed in the anode compartment and in the cathode there is the formation of ammonia, right? The zinc and ammonia combines to give a complex salt zinc ammonia. This is the thing usually deposited when the battery works on. After a certain period of time, the zinc rod will completely depleted. So, the time we will throw the battery or dispose the battery. The EMF obtained in this is 1.5 volt. There is another example for this primary battery. This is the mercury cell battery. So, this is a battery we can see in the in our wrist watches and in hearing aids. So, where there are power needed is very less. those places this button type cells are used. In this button type cell, the top layer is the anode, that is zinc. It is somewhat white in color, right? The cathode is present inside the button like shape material. This is actually the mercuric oxide, HgO. So, here the anode is the combination of zinc amalgam. If anything is combined with the mercury, it is called as the amalgam. So, it is called as the zinc amalgam. I am writing the reactions. Anode region zinc mercury plus OH minus. Why I am writing this OH minus? Because the electrolyte, in the electrolyte there is OH minus. So, this OH minus ions will get immediately attracted to the anode. Since anode is the positively charged electrode, this positively charged electrode is get attracted by the negatively charged ions present in the electrolyte. So, zinc plus OH minus giving zinc oxide plus water. In the next thing, I have written the cathode reaction, that is HgO plus water. The electrons get liberated in the anode, get added to the cathode department. I am getting Hg plus 2OH minus ions. Okay, this is the anode and cathode reaction. On adding both of these reaction, I am getting the overall reaction, that is zinc. I am written here, and this HgO, this one also I have written here. This water and water will get cancelled. Compare the reactant side with that of the product side. If one of the thing is written in both the reactant and product side, we can cancel it. So, water is present in the reactant side and it is also present in the product side. So, I am cancelling this. Similarly, the electrons also. Here the 2 electrons are present in the product side, and in this reaction 2 electrons are present in the reactant side. So, I am cancelling these things. After that, the 2 OH minus ions also get cancelled. What are the things remaining? Just I am adding zinc plus HgO giving ZnO plus Hg. Here the mercuric oxide get converted from oxidation state 2 to 1. It is reduced from 2 to 1. So, this is the mercury cell. Okay. Now, moving to the secondary battery. What is the secondary battery? The main difference between the primary and secondary battery is the secondary batteries are the rechargeable batteries. What is the rechargeable batteries? They can be charged and used again and again. So, this now we are going to see the lead acid battery. In this lead acid battery, we have taken lead as the anode and lead oxide as the cathode, and 38% of H2SO4 is taken as the electrolyte. Okay. I am taking this electrolyte in the form of ions, that is H plus SO4 minus 2 ions, for the sake of explaining the reactions happening inside the cell. First, let us see the anode reaction. Anode is lead. I have written the lead. What is the charge of the anode? Anode is positively charged electrode. In the electrolyte, we have negatively charged ions. This SO4 minus 2 ions get stick to the anode electrode. So, Pb plus SO4 minus 2 giving PbSO4, 2 electrons get liberated. This is the anode reaction. Coming to the cathode reaction, in your book they have given in a single step. For your clarification, I am dividing this into 2 steps. Okay. The cathode is PbO2, that is lead oxide. I have written the lead oxide. Here what happens, this is the negatively charged electrode, right. So, this H plus ions present in the electrolyte get stick with this. So, I am adding 4 H plus. 4 hydrogen ions get into the cathode department. The electrons from the anode side always get added to the cathode side. I am getting lead plus 2 water. So, this will be liberated as water, lead and 2 water. And to this lead again I am adding SO4. How this happen means, since H plus ions are near to the anode, then this positive charged ions in turn may get attracted with the SO4 minus ions present in the electrolyte. So, I am adding the SO4 minus 2 in the second step. This will lead to the formation of PbSO4. Now, how to find the overall reaction of the cathode means just adding as we added earlier. Here PbO2 I have written Pb. So, Pb is Pb will get cancelled since it is present in both in the reactant and in product side. 4H plus SO4 minus. So, 4H plus SO4 minus 2 I have written plus 2 electron, that also I have written, giving PbSO4 plus 2 water. This is the cathode reaction. I am adding, by adding these two steps I am getting the cathode reaction. Now, I am going to find the overall reaction. What is the overall reaction? Anode plus cathode. Anode reaction and cathode reaction have to be summed up to get the overall reaction of the cell. Just I have given the anode reaction. Once again I have written the anode reaction here, and once again I write the cathode reaction here. So, we are going to add these the entire things. See, 2 electrons and 2 electrons get cancelled. This is in the reactant side and this is in the product side. Then 2 PbSO4 there in the product side. So, I am writing 2 PbSO4, 2 water, written these things, Pb plus PbO2. So, this Pb plus PbO2 plus 4H plus into SO4, there are 2 SO4, right, 2 sulfate ions. So, 2 sulfate ions plus 4H plus giving 2H2SO4. This is the overall reaction for the lead acid battery. Don't forget to put a equilibrium arrow in this. What is this meaning? When the reaction is happening in this direction, then the cell is getting discharged. Suppose if we supply electricity to this battery, the reverse reaction will happen, that is the charging will be happen. So, this is the meaning of the secondary battery. We can charge and use it again. One more example for the secondary battery, that is the nickel cadmium cell. They have just given the reaction of overall reaction of the nickel cadmium cell alone. This is the reaction of the nickel cadmium cell. Now, we are going to see about the fuel cell. Usually in thermal power plants, coal, lignite, petrol, those are used to get electrical energy. They are used to produce water steam. Those steam is used to run the turbine, and those mechanical energy of the turbine is in turn used to make a electrical energy. But fuel cells are the one which are very efficient galvanic cells designed to convert the fossil fuels like hydrogen, methane into electrical energy. Fuel cell is designed as such, the reactants are continuously supplied throughout the entire reaction, and the products formed in the cell is also continuously withdrawn. This is the main thing in the fuel cell, that is the reactants and the products are continuously flowing into the cell. So, it is also called as the flow battery. Now, coming to the anode and cathode of the fuel cell, both are the carbon electrodes. It contains a catalytic amount of platinum or palladium just for the activation of the surface alone. It contains potassium hydroxide or sodium hydroxide as the electrolyte. Here we are supplying hydrogen and oxygen. Hydrogen is bubbled through the anode and oxygen is bubbled through the cathode. As a result of the combination of hydrogen and oxygen, we will be getting water, and this water is continuously withdrawn from the cell. Now, let us move on to the cathode and anode reaction. In the cathode we are having oxygen, right. So, this oxygen added with the water and adding with the 4 electron, we will be getting 4 OH minus. In the anode compartment, the hydrogen is added with that of the 4 OH minus. This is the positive electron, and negative charged material is get near to it. So, we are getting 4 water plus 4 electron, and this 4 electron was added to the cathode section. Now adding both the anode and cathode, we will be getting the overall reaction of this cell, that is 2 hydrogen plus oxygen giving 2 water. This is used in the Apollo spacecraft program, and it is also a drinking source for the astronauts, because we are getting water there. That water will be available in the form of water vapor, and those water vapor are condensed to give the water for the astronaut people. So, this is the fuel cell. Now, moving to the corrosion. So, what is corrosion? This is the slow and steady destruction of metals in the presence of air or water. So, this corrosion is divided into 2 types. One is dry corrosion and another one is wet corrosion. If the corrosion happens only because of the air, then it is called as the dry corrosion. We may see the greening of skin or greening of metals, greening of copper metal, that is the dry corrosion. Similarly, we can see the blackening of anklets or silver metal, that is also the example for dry corrosion. For the example of wet corrosion, the best example is rusting of iron, that is Fe2O3 X water. This is the rust, formula for the rust. Now, I am writing the anode equation, iron giving Fe+2, that is ferrous ion. It removes 2 electrons, and those 2 electrons get added with that of the cathode, that is oxygen plus 4H plus 4 electron giving 2 water. Usually in whatever metal, the metal ions are formed from the anode, and in the cathode oxygen will be formed, those added to form metal oxide. This is the principle of corrosion. Okay. Now, I have written an anode equation and I have written a cathode equation. I am going to just add these 2 reactions to get my overall reaction, Fe plus O2 plus 4H plus and 2 electron, because here there is 2 electron and here there is 4 electrons. So, 2 electrons will be cancelled and remaining 2 electrons I am writing in the reactant side itself. The product Fe+2 plus 2 water. So, this Fe+2 later react with the oxygen present in the air and converted into Fe+3, that is ferric ions. So, this ferric ions takes in the form of Fe2O3, that is ferric hydroxide, into water with some water molecules. Always remember, anodes are susceptible to corrosion and cathode never corrode. So, anodes are the thing which is very susceptible to corrosion. It is an important point you have to remember. So, to avoid the corrosion, what should we do? The simple technique, painting the metallic surface itself control the corrosion. And another thing, electroplating, that is coating of any precious metal over the base metal is known as the electroplating technique. And electroless nickel plating is also there. This will also help to prevent the corrosion. That is all of the unit electrochemistry. Let us move on to the organic chemistry in the next part.